Hello and welcome to Easy Maths. This is a video that will target the area of tangents and how that is related, or how they are related with circles, in a series of lessons on the topic of circles, chords and tangents. And so let's begin this first one, which is going to be an introduction to the area, and then we're going to have another one that will target an extended example. Let's turn there. Now, as we define the word tangent, I'm going to say that a tangent normally is a line that touches the circumference of a circle just once. For example, if we have an angle like a circle like this, the line that touches the circumference at A would be the tangent to this particular circle at the point A. Again, we should also know that a tangent to a circle at a point is normally perpendicular to the radius of the circle at the given point. That means in a given diagram, the line OA, which is the radius of a circle, is supposed to be perpendicular to the tangent at the point A. That's where the tangent touches the circumference of the circle. And this is true for all tangents, because all tangents touch the circumference at a given point, and if you draw the radius of the circle at that particular point, the angle between the radius and the tangent will always be 90. Now, next is the concept that has to do with tangents to a circle from a given point that is external to the circle. Consider the circle with center O there and the two tangents AP and BP, and of course there's a length OP like that. Now from this given diagram, we can actually say that the tangents form two similar triangles. The tangents AP and BP form similar triangles AOP and BOP. Just to prove that, consider that OA and OB are equal to the radius, and they're also equal. And if I draw them out there, I'm going to have the length OA and OB like that. Again, OAP and OBP are equal to 90 degrees because of the concept I just talked about at the beginning of the lesson there. And that's the length, that's the angle, this angle here. The angle at A and the angle at B. Angle between the tangent and radius of the circle at the points A and B respectively. And therefore, if this is true, I can add another line like this, so that I have the length AP and BP, such that the line OA and AP are perpendicular, and OB and BP are also perpendicular. Lastly, OP is common, and that means this length here is common. And if I add it over here, I'm going to have two distinct triangles, OAP and OBP, which they must be similar. We say that the triangles OAP and BOP are similar triangles according to the RHS. The R stands for right angle, H means hypotenuse, and S is an included side. The R in our case would be the angle 90 degrees, which is talked about, angle between the radius and the tangent, angle between the radius and the tangent, angle between the radius and the tangent, the radius and the tangent. I just showed that. The H is the hypotenuse, which we said is a common length, OP. OP being common, therefore it's a common distance, OP. S is included side in a diagram, OA and OB. We said is the radius of the circle, and therefore they must be equal in length, and therefore we can confidently say that AOP and BOP are also similar triangles. Additionally, we can say that the distance AP and BP must be the same in length. AP and BP must be the same in length. They're not just corresponding, they're actually equal dimensions in terms of their length. The angle AOP and BOP, they must be equal. And APO, that's the angle APO and BPO must also be equal. And that brings me to the end of the first lesson there on touching on tangents and how they are related with circles. Check out the next video, which has to do with an extended example on the same area. And as always, please like, share, subscribe. I'll appreciate. I'm targeting to hit 1,000 subscribers, and so your subscription, even your comments, will go along in helping improve content and help someone out there. Thank you.